Good morning, class. I guess we have reason to celebrate. This is our final class meeting. It's been somewhat challenging to deal with the online nature of the course, but it worked pretty well, I think. So before we do our new topic, let me make some comments about how we're going to manage the course. Your second test and your fifth quiz have been graded. Your grades are available. I think what I'll do is send you, since it's a small class, send you individual emails, and I'll tell you what these grades were. I'll point out where your problems were, where you missed points. I'll give you your average for your tests and your quizzes. The final exam, you should have it at the end of the week. So I'll try to finish it tomorrow, email it to you, get it in the mail. It should arrive in the U.S. mail Friday or Saturday at the latest. And you need to submit your work on the final exam. It is a take-home exam by Tuesday, May the 5th. Drop it in the post office not later than May the 5th. I need to have time to grade it and report your grades. So now you might wonder, why are we even bothering with this final exam? Couldn't we just exempt everyone from taking it? You can make a case for doing that. I'll give you some reasons, though. For one thing, the recent material in Chapter 4, there hasn't been a test on that material. And that's something like a third of the course. And it's a good idea to review the entire syllabus of the course, especially what we did at the beginning of the semester. That was a few months ago. And then a third reason, and this can be significant, is you may have an opportunity to improve your course grade by a letter. Think about it. If you make 100 on this take-home exam, it might bump you up from a C to a B or from a B to an A. So take it seriously, and maybe your grade will improve. Okay. So we've learned how to multiply matrices, and we've learned how to find the inverse, at least of a 2x2 matrix. We haven't indicated why we have those operations, what they're good for. If we were doing the whole course on linear algebra, I could make a stronger case. Let me first mention a very simple application of matrix multiplication, is finding course averages. So you remember your the way the grading works in this course is the quizzes are 3/10 of the grade, the tests are 4/10, and the final exam is 3/10. So if I have my grade book here, so we have quiz average, test average, and final exam grade, and then student 1, student 2, student 3. So we might have a situation like this, 80, 70, 70, 60, 70, 90, 80, 80, 100. Someone got serious there and made 100 on the final. Okay, so here's students 1 grade, students 2's grade, students 3. And if over here I have 0.3, 0.4, and 0.3, when I do that multiplication, I come out with the course average of the students. So this first one, for example, would be 80 times 0.3 is 24, 70 times 0.4 is 28, 70 times 0.3 is 21, I believe. So that student has a course average of 73. Presumably he or she would make a C in the course, etc. So there's a simple example. Now, I don't know if I could do it this semester because the final exam is not proctored, but I sometimes allow students to assign more weight to the final exam. So I could do, I could adjust these weights like this, for example. I could make this 0.5 and 0.3 and 0.2. So now the final exam is half the grade. The test average is 3/10. The quiz average is 2/10. I could calculate those averages in the same way. Okay, so that's one application, matrix multiplication. The one I really want to talk about, though, is a quick and easy way to solve non-singular linear systems. So you remember these are systems that have exactly one solution. So let's have an example or two of this. All right, so suppose we want to solve 2x plus y equals 3, and 6x plus 4y equals 1. Now we know various ways to do this already, but if we want to use matrices, we can do the following. Now I'm not talking about Gauss-Jordan elimination. This is a new method. So here's what we can do. We define three matrices. 'So we have the matrix of coefficients, 2, 1, 6, 4. Two, 1, 6, 4. We have the matrix of constants, 3, 1. And we have the matrix of unknowns. And we're going to write y underneath x rather than to the right of x. Okay, now here's the amazing thing, class. If we say m times u equals c, that's exactly this system here. So the matrix equation m times u equals c is exactly equivalent to this system here. we'll look at m times u. So 2164 times xy. So 2 by 2, 2 by 1. So the answer is going to be 2 by 1. What is it? 2x plus y and 6x plus 4y. Now, this is not 2 by 2, it's 2 by 1. This is a single entry, and this is a single entry. So that needs to be stressed. So this is 2 by 2, 2 by 1, and this is 2 by 1, not 2 by 2. Now, when we say m times u equals c, so here's c, 3, 1. When we say a matrix equals another matrix, we're saying they have the same dimensions, 2 by 1, 2 by 1, and the corresponding entries are equal. So when we say m times u equals c, we're claiming that this equals this. In other words, 2x plus y equals 3 and 6x plus 4y equals 1. That's exactly this system here. Okay, so we see a connection, a more significant connection or application for matrix multiplication. Now to solve the system, all we have to do is, and this is a very fast way to solve the system. We just calculate u equals m inverse times. Okay, so we find the inverse of this matrix and then we multiply it by that matrix. So from last time, we inverted this matrix. It should be, you can check the previous video. So m inverse turned out to be 2 negative a half minus 3 1. Okay, and now we calculate xy. So it's this matrix times this one. Okay, 2 by 2, 2 by 1, so we can multiply. The answer is going to be 2 by 1. Okay, 6 minus a half, 12 halves minus 1 half is 11 halves. And negative 9 plus 1 is negative 8. So the answer is x is 11 halves, y is negative 8. All right, let's substitute in and verify that. So put in these numbers into the equations. So 2 times 11 halves is 11, and 1 times minus 8 is minus 8. So 11 minus 8 is 3. 6 times 11 halves is 33, and 4 times negative 8 is 32. So 33 minus 32 is 1. Okay, I want to keep these videos short, so I'm not going to stop and prove this for you, but let me give you another example for you to practice. So when you have a 2 by 2 system like this, how can you solve it by this method? Look at the matrix of coefficients, find its inverse, and simply multiply that matrix by the vector of constants here. Just multiply the matrix inverse by the vector of constants. Here's an example for you to practice. So I'll write it down, and then I'll give you a chance to freeze the video. All right, so here's the system we want to solve. Okay, so solve by our new method. All right, so the solution goes like this. So you have this matrix 3, 1, 8, 4. And you have the vector of constants here. So the first thing you do is find M inverse. And then the second thing you do is you calculate M inverse times C, and that'll give you your answer. Okay, so now you should freeze the video and work this out. I'm going to stop for just a second or two. Okay, here are the answers. This turns out to be 1 minus a fourth minus 2 3/4. And when you multiply, you get, it's a little tricky, the arithmetic, 13 over 4 and minus 23 over 4. Hope you can read that. 13 over 4 and minus 23 over 4. Okay, class, that's the end of our course. I look forward to getting your final exam from you, and I hope you do very well on it. Try to make 100 on the final exam. Maybe that'll get your letter grade raised by 1 letter. I'd like to see that happen.